4 billion miles from where you're sitting, a moon smaller than our own is covered in a deep red stain scientists can't fully explain. And its planet next door may have blown its top with something that wasn't lava at all. Stick around because NASA just confirmed details about this system that are stranger than anything New Horizons photographed back in 2015. Welcome to Infinity Alert. Today we're exploring a frozen moon that scientists say shouldn't have the chemistry it does, orbiting a dwarf planet that may have erupted from the inside out. For decades, Pluto's largest moon, Charon, was treated as the boring half of the story. Discovered in 1978, almost half a century after Pluto itself, Charon is roughly half Pluto's size, large enough that the two worlds don't really orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other. A silent standoff that has been running for billions of years. Most of Charon's surface is unremarkable water ice, ancient, heavily cratered, geologically dead. Except at its north pole, which is stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. For years, researchers suspected a connection between that coloring and material escaping from Pluto itself, but they lacked the instruments to confirm it directly. And separately, on Pluto's own surface, two enormous isolated peaks rise out of the landscape that scientists still can't fully explain. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes on Earth. Both have deep depressions at their summits, ringed by fractures, with lumpy, uneven flanks that closely resemble cooled lava flows, except there's no molten rock on Pluto. So what's actually going on with these two frozen, tidally locked worlds? Let's start with Charon's red cap, because the mechanism behind it is genuinely strange once you understand it. Because of the way Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time, with no sunlight reaching it at all. That makes the pole an extremely effective cold trap. Methane molecules that have escaped from Pluto's thin atmosphere drift across roughly 12,000 miles of space, get captured by Charon's gravity, and freeze solid onto that dark polar surface, simply because there's no warmth to keep them as gas. They sit there accumulating for years. Then, when sunlight finally does return to that part of the moon, it doesn't just melt the frozen methane away. Instead, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds called tholins, essentially locking in that dark coloring permanently rather than letting it evaporate back into space. Two worlds, locked together, quietly exchanging atmosphere and color for billions of years, long before either one had a name. Now to Pluto's mysterious peaks. If these features are what they appear to be, they're cryovolcanoes, structures that erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Researchers remain divided on whether these formed from a handful of massive eruptions or many smaller events spread across a longer stretch of time. Either interpretation points to the same conclusion. Something beneath Pluto's frozen shell was warm enough at some point in its relatively recent geological history to force liquid material all the way to the surface. To understand how strange that is, it helps to actually stand there for a moment. Imagine the surface beneath your feet. At nearly 400 degrees below zero, water ice doesn't behave like ice here at all. It stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. Overhead, the sun would appear as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare. You could look directly at it without discomfort. The sky itself would sit in a permanent grayish-blue gloom, thick with haze, never fully day and never fully night. And fixed in exactly the same spot in that sky, never rising or setting, Charon would hang there motionless, a consequence of the same tidal lock that keeps these two worlds forever facing each other. For anything to erupt and flow across ground that cold and that hard, whatever forced it upward had to be under serious pressure from somewhere deep enough to still hold on to real warmth. If you're the kind of person who wants space stories explained clearly instead of buried in jargon, go ahead and drop a like right now. It genuinely helps this kind of content reach more people. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used James Webb Space Telescope data to confirm the presence of both carbon dioxide and hydrogen peroxide frozen directly onto Charon's surface, a specific combination of frozen chemicals that had never been confirmed on Charon before. According to the published research, the carbon dioxide most likely originated from underground material exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and rearranging it into something new. This matters because it means Charon isn't just a passive, dead ice ball catching Pluto's leftovers. It has its own active surface chemistry, still being reshaped by radiation today. On the cryovolcano question, earlier data comes from NASA's New Horizons spacecraft, which flew past the Pluto-Charon system in July 2015 at more than 30,000 miles per hour, capturing the only close-up images either world has ever received. It had exactly one chance. No orbit, no second pass, just a narrow window of a few minutes before continuing on into the darkness of the Kuiper Belt forever. Scientists analyzing that flyby data have argued that the lumpy, jumbled terrain covering Pluto's two largest peaks doesn't match any known impact or erosion process. The best available explanation remains cryovolcanic activity. No orbiter or lander has ever returned to confirm this directly, and no mission is currently funded to do so. The outer solar system rarely gets funding priority over closer, faster targets, since a return trip alone would take the better part of a decade. So for now, New Horizons' single flyby and Webb's ongoing infrared observations remain the only tools researchers have. That internal warmth needed to drive cryovolcanic activity leads to one of the most debated ideas surrounding Pluto today: the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept in a liquid state by the slow, radioactive decay of elements inside Pluto's rocky core. The evidence isn't a photograph, it's a pattern. Cracks and ridges across Pluto's surface line up in ways that fit what you'd expect from a subsurface layer of liquid water shifting slowly beneath the crust. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons, both of which show far more obvious surface evidence, including geysers of water vapor erupting directly into space in Enceladus's case. If a body as small and as cold as Pluto turns out to be hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed. Pluto and Charon aren't the only pair worth watching either. Out in that same distant region, the dwarf planet Eris, slightly more massive than Pluto, though a bit smaller in diameter, has its own large moon, Dysnomia, orbiting closely enough that researchers have used their mutual motion to measure Eris's mass with real precision. Makemake, another Kuiper Belt dwarf planet, has a much smaller, faint moon that's barely been resolved even by Hubble. Neither system has been studied anywhere near as closely as Pluto and Charon, simply because New Horizons only ever flew past one of these pairs. If a tidally locked binary as small as Pluto and Charon can be actively exchanging chemistry the way current data suggests, it raises a real question researchers don't yet have the instruments to answer. Whether similar processes are quietly running on Eris and Dysnomia, or Makemake and its moon, unseen simply because nothing has ever flown close enough to check. Here's the detail that tends to stop people in their tracks. The same basic chemistry that stains Charon's pole red, sunlight breaking apart simple molecules into heavier organic compounds called tholins, belongs to the same broad family of chemistry some scientists believe may have once rained down onto early Earth, potentially contributing raw material for the kind of reactions that eventually led to life here. On Charon, that process has been running for roughly 4 billion years, a slow, continuous transfer of organic material between two worlds, landing on a surface too frozen for any of it to ever spark into something alive. And to put the scale of this system into perspective, sunlight reaching Pluto and Charon is roughly 1,000 times fainter than sunlight reaching Earth. Even at high noon, the sky there would look closer to a heavy twilight here, and yet even that faint trickle of light is enough to drive the chemistry staining an entire moon red, and possibly enough, over billions of years, to help keep an ocean liquid 100 miles beneath a frozen crust. So what does this actually add up to? Pluto and Charon aren't a dead planet and a boring moon quietly circling each other in the dark. They're two worlds actively exchanging atmosphere, chemistry, and possibly heat, one apparently venting material from deep underground, the other catching that material and rebuilding it into something new at its pole, one radiation-driven reaction at a time. If Pluto really is hiding a liquid ocean, and Charon really is running an active chemical process at its surface, then the case for treating small, distant, icy worlds as geologically dead gets weaker every year. And Eris, Makemake, and their own moons may be next in line for that same reconsideration. Webb is still watching this system, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thank you for watching Infinity Alert. Stay curious, stay inspired. See you in the next journey through the universe.